right, corn children, this is my second attempt at a logarithmic differentiation video. Here's the problem. Y equals x times the square root of x to the fourth plus 1. And our directions are to find the derivative of y with respect to x. And you're going to notice right away that it seems like an odd title, logarithmic differentiation. There are no logarithms in this problem. We do have a product with a chain rule, and that seems kind of yucky, but there's no logs. Well, here's the idea. Let's say you want to dodge having to do a product chain rule. After all, that might be messy. You can actually get away with that if you introduce logs into the problem. Out of nowhere, we are going to take this equation and we are going to take the natural log of the left and we will take the natural log of the right-hand side. The logs were not in the problem to begin with. Why? Why would we do that? We want to use the laws of logs to break this up. But you can't do that unless you have logarithms. So here's what it looks like. Left-hand side, we have the natural log of y. On the right-hand side, we have the log of a product. We can break it up with addition. And instead of keeping this 1/2 power here, I'm going to make it a coefficient. So I have removed the product from the problem by introducing logarithms. All right, so now what? Well, now we will take the derivative. This is an equation, and I'm going to need to take the derivative with respect to x of both sides. Now, do not ignore the right-hand side, or the other right-hand side, the left-hand side. Do not ignore the left-hand side. This is not just y, this is the log of y. So we need to follow the rules here. The rules are that I put the y in the bottom and its derivative in the top. Well, the derivative of y with respect to x is dy dx. This is the u and the u prime from our flashcard. Interesting. Right-hand side. Straightforward. We're going to put the x in the bottom. The derivative of x is 1 plus scalar of 1/2. There's the 2. X to the fourth plus 1 in the bottom. Its derivative in the top. Oh, those cancel. You're welcome. Now, because I know we need to do a lot more work with this, I am going to bother to get a common denominator here. I don't usually, mess around with that, but we're going to need it in this particular case. So we have a denominator of x, x to the fourth plus 1. I'm going to multiply by a form of 1, x to the fourth plus 1 over x to the fourth plus 1. In order to get this x in the other one, I need to multiply by x over x. Left-hand side stays this mess. Don't forget, it's not just dy dx, it's dy dx all over y. Right-hand side, common denominator. Now look carefully at the numerator. We've got x to the fourth plus 1 plus 2x to the fourths. So I've got 2x to the fourth here and an x to the fourth there. That's 3x to the fourths, and that plus 1. Now you might say to yourself, yay, we're done. We are not done. We're not done because we haven't solved for dy dx. This isn't dy dx, it's dy dx divided by y. Well, it's still an equation. You're allowed to multiply by y as long as you do it to both sides. On the left the y's cancel and you have dy dx. We were asked to find the derivative of y with respect to x. And you might think you're done. You're not done. Here's the problem. We have x's and a y. I'd really like this, you really need this, all in the single variable of x if at all possible. And it's possible. This y. Isn't this y defined in the original problem? We are going to take the original problem and substitute it in for that y. That's exactly what we're going to do. Here we go. 3x to the fourth plus 1, x to the fourth plus 1 times 1 over y in the top, original problem. The original problem without the radical, but with a 1/2 power. Hey, look what I see. These x's cancel. You're welcome. Wait for it. X to the fourth plus 1 to the first. X to the fourth plus 1 to the 1/2. When we divide, the exponents subtract. Subtracting 1/2 and 1, you get a 1/2. There's more in the bottom. All of these cancel, and this becomes a positive in the bottom, 1/2 power. If you had it in the top, it'd be a negative 1/2. I'm going to drop it already to the bottom. So here's where we end up. dy dx, 3x to the fourth plus 1 over the square root x to the fourth plus 1. Booyah!